Hello and welcome to this tutorial. We're going to be taking a very close look at EIGRP routes. Now so far we've taken a look at the metric used in EIGRP, and we took a look at the different factors that it's based on. And we've also taken a look at how routes are calculated and what happens when a network failure occurs. Well, at this point, what we really need to do is to see these firsthand, to actually see them on a router and go through all the details. Until we do that, it's nothing but theoretical information. So we're going to start off by taking a detailed look at EIGRP routes in the IP route table to make sure we understand all of the information that's presented to us. After that, we'll take a look at the EIGRP topology table and see what details are located there, and this fits in nicely with how the routes are selected. Now in doing so, we're going to talk about the successor and the feasible successor routes, which means we also have to talk about the feasible distance and the reported distance. The good thing is all of this information is going to be present and viewable on the router. Here's our network setup for this tutorial. Routers A, B, and C. Router A is an EIGRP neighbor with both router B and router C. And router A will be receiving route information from both of those routers. So we're going to log into router A and run all of our commands from there. Okay, let's begin by confirming our EIGRP neighbors on this router. And we have router B and C, so that looks good. We'll begin with the show IP route command. And I can immediately tell we have one route in the IP route table from EIGRP. And that's because in the first column I see the letter D, and according to the key, D means this is an EIGRP route. All of the C's mean that those are connected routes. The S means it's a static route. Make sure you're familiar with the key so that you can immediately identify the type of route, okay? Now right after that we have the route itself, 192.168.2.0/24. That's what was advertised to us. Immediately after that we have two values in the brackets. The first one is the number 90, and that is the administrative distance for EIGRP. If you're not familiar with that concept, take a look at the administrative distance tutorial in the ICND1 material, okay? Now the second value, 409.600, that is the EIGRP route metric for this /24. And we're going to be seeing more of that in just a minute when we take a look at the EIGRP topology table. Alright, so administrative distance followed by the route metric. Now after that we see the IP address 172.16.1.6. That is the next hop. So if we need to send a packet towards anything in that /24, the next hop is that IP address, and we can reach that via Fast Ethernet 00. So that's the local interface that we would exit upon sending a packet in that direction. Okay, so that's all of the information for that one route in the IP route table. We can also find some more details if, after the show IP route command, we enter the route that we're interested in. So 192.168.2.0. And you can see here we're only getting information about that one route, and we're getting a lot more information. So we're not going to cover everything here, just some of the highlights. We can see which process we learned it by, EIGRP with the AS number 21. We can see the distance of the protocol, so that's the administrative distance, which is 90. And then it's telling us here the metric, 409.600. All of this information is the same as what we just looked at. On the bottom, we can see it again, but this time I want to point out the delay. You can see it here, 6,000 microseconds. We also list the bandwidth here, 10,000 kilobits. That equals a 10 megabit per second link. And then you can see we have reliability, MTU, and the load. So we have all of the factors of the EIGRP metric here. The delay, the bandwidth, reliability, and load. Okay, so from these two commands we can learn a lot of information about this single route. Okay, so now let's take a step back and take a look at the EIGRP information before it actually gets into the IP route table. To do that, show IP EIGRP Topology. So we're going to take a look at the EIGRP Topology table. Okay, here it is, and you can see we have 3 routes listed. 172.16 1.4 and 1.0, those are both the directly connected routes. So the one we're interested in is the one we just looked at, the 192.168 2.0/24. Now you can see here we have one successor, and it says here the FD is 409.600. The FD here stands for the feasible distance. That's what the router calculated. Remember that 409.600? That was the metric we saw in the IP route table. Okay? Now just below that, we see that we learned this route information from 2 neighbors. And here we have router C on top, 1.6, and then we have router B, 172.16 1.2. Each of those has a parenthetical after it with 2 bits of information. The first number is the feasible distance. So you can see here quite clearly router C, 409.600, that feasible distance is the lower of the 2. Router B has a much higher feasible distance, 230.6560. Okay, so just based on that alone, the router calculated the feasible distance for each of those routes and selected the lowest one, and that became the metric for that route, and then it's put into the IP route table. Now the second value in the parenthetical, the 128.256, that's actually the same between both of these 2 routers, and that is the reported distance. In other words, that's the metric that router B and router C sent along with the route 192.168 2.0/24. Now at the end you can see the interface that we learned each of the 2 routes on, Fast Ethernet 00 and the serial. So understanding that EIGRP uses bandwidth as one of the factors, well, it's easy to understand why the route from router C was chosen, because it's a Fast Ethernet link. It has more bandwidth, so that was able to lower the internal calculations when router A received that route information, and that's why that route has a lower feasible distance than the one from router B, because router B just has a serial interface to router A. So we know our feasible distance is 409.600. That means that the route from router C is our successor. Now, is the route from router B a feasible successor? Well, when you issue the show IP EIGRP topology command, it will only list successor and feasible successors for each route. So right off the bat, you know that the route from router B is a feasible successor. However, there is a very simple way to determine if a route is a feasible successor or not, and this is how the router actually does it itself. In order to become eligible, to become a feasible successor, there is a requirement a route has to meet, and this is known as the feasibility condition. And quite simply, it states the reported distance has to be less than the current feasible distance. Okay, so the reported distance has to be less than the feasible. So if we look at the reported distance from router B, 128.256, if we compare that to the current feasible distance of the best route, 409.600, it is less than that. So it is then a candidate, it is then a feasible successor to the successor route. All right, so if you're ever presented with a question or on-the-job challenge to determine if a route would become a feasible successor, that's how you do it. Okay, so at this point, let's go ahead and take down the link between router A and router C and see what happens. Okay, I've just taken down that link. Let's take a look first at the EIGRP topology table. You can see we still have both routes in there. Now, why is that? Well, this fits back into the timer tutorial, where we have the hold timer and the hello timer. On this link, it defaulted to 5 and 15 respectively. So router A is going to wait at least 15 seconds before declaring router C as down, because now router C can't send us any hello messages. Let's take a look again to see what's happened. Okay, you can see 15 seconds have passed, and now we only have a single route in the route table here, the EIGRP topology table, and that is from 172.16.1.2. Okay, that is the serial link to router B. If we cycle through and just take a look at our route table now, you can see here the information has already been updated in the route table, and you can see 192.168.2.0/24. The administrative distance is still the same because this is still an EIGRP route. However, after it, you can see the metric for this particular route has changed, 230.6560, because it was a lot higher, because this is now the route from router B. Obviously, the next hop information has changed to router B, and the serial interface that we use to get there is now listed instead of the fast Ethernet. Okay, so you can see how quickly that changed once we took down that link and the hold timer expired. Okay, so let's go ahead and summarize what we covered. We took a look at the show IP route command, and we saw that inside those brackets we have the administrative distance and the feasible distance, the route metric that EIGRP is using. And then we took a look at the EIGRP topology table. In there, we again have the feasible distance for each of the routes. However, we also have the reported distance. Then we took a look at how a route is considered to be a feasible successor, and the formula is pretty simple. Is the reported distance less than the current feasible distance? If it is, then that route is a feasible successor. And then finally, we did a quick convergence test, and we saw that once we brought down the link to router C, the feasible successor was then promoted to the successor route, and then that was updated in the IP route table. Okay, so that's it. That is a closer examination of the EIGRP routes. Thanks for watching.